Okay, good evening. We are going to start into our final little set of videos. We're going to get through chapter 6 here with three and a half videos on the polynomials stuff this week, and then we're also going to get through the final half of chapter 5 later on, not this lesson, but later on in the week for the Math 05 too. So we'll have looked at everything, and we've already early in the course looked at pretty well everything that's in the O2 and O3 as we went through the first two chapters of the O5 course, which reviews those same concepts. So here we go. This is a big one. We're gonna go through all the 6.1, 6.2, and 6.3 right now. Now that sounds worse than it is because 6.1 is really you can do 6.1 once you know how to do 6.2. So we're going to do it in that order. So first of all, we're going to talk here about this thing. I've got that word on the screen, polynomial. What is a polynomial? You don't really need to ever reproduce this definition, but just so you understand, it's a collection of added and subtracted terms where each term has a coefficient in front and a whole number power of the variables. So look at these. We have pieces being added or subtracted, right, in each of these. And remember, the way we think about this is every term is either positive or negative. And if it's the very front one and happens to be positive, we're lazy and we don't put it there, but we know there is a plus in front of that 3x squared and a plus in front of that t to the fourth. When you first look at this, I said that each term has a whole number power of the variable. And you can see I put in red there the powers of variables. Kind of looks like not all the pieces have powers of variables, but actually every single piece does. For starters, look at this x here. We just write x, but we know if we wanted to, that is actually x to the 1, right? So we don't bother to write it. Don't start writing power of 1 after all your variables that are by themselves. You don't need to, but it does fit this definition. And again, when we look at these constant terms, it doesn't even seem to be a variable at all. And again, never do this, but just so you see it fits the definition. Technically, if we really wanted to, we could write an x to the 0 there, because you remember that anything to the power of 0 is 1. Right? So now you see that, in fact, even though we're too lazy to write some of the things like powers of 1 or powers of 0, every term does, in fact, have a whole number power of the variable. Whole number, what does that mean? A reminder, that's all of the counting numbers, 1, 2, 3, 4, 5, 6, and so on, as well as 0. No negatives, no fractions, no roots. So the powers are all whole numbers. The coefficients can be negatives, fractions, and roots, but not the powers. Okay, so that's the whole number powers. What about the coefficients? Well, those are just the numbers in front, which I put in blue there. And you look over at this one on the right, it doesn't look like it has coefficients, but it does, because remember that when the coefficient is a 1, we don't bother to write it, but we know it's there. So the coefficient here is a positive 1, and the coefficient here is a negative 1. Again, notice how the positive and negative signs go with each term, right? So this is a positive 3, a positive 5, and a negative 6, a positive 1, and a negative 1. Each piece that is separated by a plus or a minus we call a term. And so if we count up how many terms these have, look at this first one. There's a plus and a minus, so we have the 3x squared out front. It's not going to let me highlight it, is a term. The 5x is a term, and the negative 6. So you see things can be multiplied, right? But that doesn't make it a separate term. It's the pluses and minuses that separate the terms. So why don't you just take 15 seconds and identify how many terms are in each of these two polynomials. Okay, so if we look at this, we have this first piece here, second piece here, third piece here, and a fourth. So 4 terms in that one. And again, notice every term is either a negative or a positive. This negative here in front of the 6 has nothing to do with the 5x in front of it, right? Only to do with the number that follows it. And this last one here just has two terms, the t to the fourth and the t squared. Degree. So the questions will ask you the degree of a polynomial. It's very simple. It is simply the highest power that the variable has. So if we look at this first one here, this is an x to the 1, right? This is an x to the 2. The 2 is the highest one. So there we go. There we go. The degree of that polynomial is 2. Now, I happen to write all these in order of decreasing powers, which we tend to do, but they don't have to do. So just be careful. It might not be the first term. I think I said to try these. Let's not bother. Let's just skip through that. So the highest power of a in this equation is 5, so it has a degree of 5. And the highest power of t is a 4, so it has a degree of 4. Again, I should have put one in where I had mishmashed or mixed up the order of the terms, because you're looking for the highest power, which may or may not be the first one that they list for you. Okay, so we already have done some expanding brackets, so that makes a lot of this chapter quite a bit easier for us, because we know the basic idea. It's called the distributive property. And by the way, chapter 6 is kind of broken into two halves. The first half is all expanding brackets, and the second half is trying to figure out how to go backwards and unexpand the brackets, basically, which is called factoring. So we're going to get through all of the expanding stuff during this lesson. So this is something we already know how to do. So why don't you see if you can remind yourself by expanding those brackets, multiplying the thing out front through the bracket. Okay, so this is a reminder from way back at the start. You did this in the first couple chapters in the review. So we remember that we want to take that 3 and multiply it by both the x and the 5. 3 times x is positive 3x, and 3 times 5 is positive 15. Now, that plus there, obviously in front of the 3, we don't need that, right? I'm going to start to put that in here because you are going to see, I think I talked about this, yeah. So that plus in front of the 3, it's there even when we don't need to write it. And we usually haven't bothered to put it there. But in this chapter, you're going to find there are situations where it is really important that you do put it there. And we'll see what that is very soon. So just because we're so used to not bothering with that plus sign, sometimes students continue to not bother in the situation when you actually really, really need it there. So sort of consciously, every time you expand a bracket and the first term happens to be positive, you want to think to yourself, do I need to put the plus there? Am I not sure if I need the plus there? If you're not sure, put it there. You can always just drop it in your final answer if you didn't need it after all, right? Here we're going to run the negative 8 through the bracket. So negative 8 times t, that's just negative 8t. And you see when the leading term is negative, we have to put it there, right? Unlike over here. And negative 8 times negative 1 is plus 8. So again, you see how every term ends up having a plus or a minus with it, even when we don't bother to write it. So there is the second one expanded. This bracket has 3 pieces, so we take that 7 and we multiply it through all 3 of them. 7 times y squared, which is positive 7y squared. Even if we don't need to write that, we know it's there. 7 times 4y is positive 28y. And 7 times negative 2 is negative 14, like so. And we say, okay, we didn't need that leading plus after all, even though we know that it's there. So there's a quick reminder of expanding brackets. We're going to step this up a little bit here. First of all, we could have 2 expansions to do in the same expression. So here I got to run the 6 through the first bracket, and I got to run the positive 3 through the second bracket. And you hear how lazy we are, right? I didn't say that positive 6, but really it is a positive 6 that we're running through the first bracket and a positive 3 that we're running through the second bracket. So here we go. 6 times b is positive 6b. Every term has a plus or minus, even if we don't need to write it. 6 times negative 5 is negative 30. Positive 3 times b is positive 3b, and positive 3 times positive 2 is positive 6. And I think I'm going to, yeah, so once again, that plus there is not necessary. We don't need to put that plus there. It doesn't make a difference, right? If the plus is there or not there, it's the same thing. That plus there is absolutely critical, because if we didn't bother to write that plus down, which I see all the time students do, what does that say now? 6b minus 30 space 3b plus 6. No, it's not 6b minus 30 space 3b plus 6. It is 6b minus 30 plus 3b plus 6. And again, technically there's that one there as well. That one way out front we don't need, but this one we do, even though you could have just gone 3b plus 6, just multiplying that through, but it's not just 3, it's positive 3, right? Okay, I'm just going to leave them both in for now, and let's do now we're going to collect our like terms. So you see that we have some b's here and here that we can join together, and some constants here and here that we can join together. So I'm just going to reorder things there. You don't have to take that step, but if it helps you to reorder the terms and put the like ones together, by all means, you can do that. And we have positive 6b and positive 3b. That makes positive 9b. Then we have negative 30 and positive 6 makes negative 24. Put those together in a final answer, 9b minus 24. And I'm going to keep harping on this. Every term has a plus or minus in front of it, right? The plus there from the 6 has nothing to do with 30, so we don't go 30 plus 6. It's a negative 30 and a positive 6. Think of them all separately. Every term is separate, its own thing, and they're all either moving right or left on the number line. Okay, now here, when we have a bracket that doesn't appear to have a number in front of it, all you got to do is remember that it is actually a 1 in front of it. So that first bracket has a 1 in front of it. The second bracket has a negative 1 in front of it, just like that. And once you know that, all you got to do is expand each bracket separately, and expanding with a 1 is dead easy, right? Multiply 1 by all these things, and they're just the same, right? And notice again, I stuck that positive in front of the first term just in case it's important. I don't think it's going to be in this case, but just in case. And this second one, we're going to take that negative 1 and run it through the second bracket. And multiplying by negative 1 is pretty easy as well. All it does is flip the sign. So positive k cubed becomes negative k cubed, and I left the 1 in there just to help remind us. Negative 1 times 4k squared is negative 4k squared, and negative 1 times negative 7k is positive 7k. You can see that keeping this 1 here is handy for a second reason, because we're about to collect like terms, which means I'm going to put all the red k cubes together, the blue k squareds together, and the purple k's together, like so. Just move the pieces around. And so some people will see 4k cubed minus k cubed without the 1 written there, and they will think that that does nothing, but it's not nothing. It's 4k cubed minus 1k cubed, so 4 minus 1 is 3k cubed. 5k squared, so positive 5 and negative 4 is positive 1. Negative 2 and positive 7 is positive 5. And now let's write a final answer, but let's drop off the things we don't need to write. We don't need the plus out front, but we do need these 2 pluses. And we don't need that 1 in front of the k squared. So you would write your final answer like that. 3k cubed plus k squared plus 5k. Even though you know there's actually a plus there, we're too lazy to write, and there's actually a 1 there, we're too lazy to write. Okay, what we just did is all, this screen right here, not even everything we've done so far, just this screen is all of section 6.1, but the book shows you to do it in a different way. And usually students get confused, and I show them this option with putting the 1s in front of the brackets, and it makes perfect sense. So I'm just skipping entirely the other way the textbook does that question and suggesting you do it this way, which is actually what you learn in section 6.2. So if you know how to do section 6.2 and you know that there's a 1 in front of a bracket, if you don't see another number there, then you can already do section 6.1. Okay, next, when we expand brackets, we might run into our exponent laws now that we've learned them in chapter 5. So we have a 3x squared y out front that we want to multiply through this bracket. Same process. We're going to multiply it by everything individually. So let's take it bit at a time. I'm going to multiply 3x squared y times 5x. And remember, when we do this from chapter 5, we multiply the matching things. So 3 times 5 is, I've done it over here on the side. Look at that. There's the 3 multiplications we're going to do, right? We're going to multiply 3x squared y by each of these 3 things. So when we multiply by 5x, 3 times 5 is 15. X squared times x is x cubed. And then there's also a y hanging out there that came along for the ride, so it's still there. Next one, 3 times negative 2 is negative. Oh, sorry, I stuck a positive. So again, just in case it's important, we know that even though we often don't need to write it, we do know there is a plus sign in front there. 3 times negative 2 is negative 6. X squared times x to the 1. We don't bother to write x to the 1, but it is x to the 1 is x cubed. 2 plus 1 is 3. And y to the 1 times y cubed is y to the 4, like so. And then the last one, 3 times 1 is positive 3. And of course, yeah, anything you multiply anything by 1 and it doesn't change it, right? So multiply the whole thing by positive 1 and it just stays positive 3x squared y. Again, notice I'm recognizing that every term has a plus or minus, even if I don't actually necessarily need to write them. Let's move these numbers over here. So there's our 3 multiplication results in red, blue, and purple. And we would look to see if there's any like terms to collect, but there's not, because like terms have to have the exact same set of variables and powers, remember? So this one has x cubed y, which is not the same as x cubed y to the 4th, or x squared y. They're all different. I showed this over on the side here and did each of those separately. Once you get practiced, I don't think you need to do that. You just take the 3x squared y, you go 3 times 5 is 15, x squared times x is x cubed, and y is still there as well, right? So you can do this without rewriting all the stuff over on the side. So there's our final answer. The positive in front of the 15x cubed y turns out to be not critical, but the positive in front of the last one, 3x squared y, is critical. That needs to be there. Okay, so yes, so now we're going to multiply brackets where the brackets, 2 brackets, both have more than 1 term. So like that. So far, this is new. So far, we've only multiplied a single thing into a bracket. So when you have here 2 brackets being multiplied, and look at, they both have 2 terms. I'm going to stress this. Let's go back and look at the last question. This thing being multiplied out front here, 3x squared y, is 1 term. It's all multiplication, a single term. Just multiply it into the 3 things, right? Each of these is 1 term. 5x is a term. 2xy cubed is a term. 1 is a term. Now look at this one. This bracket has w plus 5. That is 2 terms. And w minus 1, 2 terms. If you're multiplying brackets that have 2 terms each, you need to multiply every single term in the first bracket by the entire second bracket. Or you can actually do it the other way around as well, but I'll just stick to this one. So there's the 2 terms in the first bracket. I'm going to take each of those and multiply them by the second bracket. I'll let you stare at that for a second. You see the red W got multiplied by the entire second bracket, and the blue plus 5 got multiplied by the entire second bracket. And I know technically, if it comes up, that there is a plus sign in front of that W as well. So we take everything in the first bracket and multiply it by the entire second bracket. Now it's a question that we know how to do, right? Multiply the w through the first bracket. W times w is w squared, and I did throw the positive in there just in case. W times -1 is negative w. Positive 5 times w is positive 5w. And there's another one you see where if you just went 5 times w and wrote 5w and you didn't write that plus sign, you would have a problem, right? So the plus in front is often important. And then positive 5 times -1 is -5. Okay, now we're going to check and see if there's any like terms. Well, there is in this case, because look at this term here, the negative w and the positive 5w have the exact same set of variables and powers. I'm going to remind myself that when I see a negative w, there we go, yes. So when I see negative w, without bothering to write a number in front, there is in fact a number in front. It is a 1, right? So w squared minus 1w plus 5w minus 5. We're going to collect the middle two because they are like terms. -1 and positive 5 add to positive 4. And there is our final answer in a box. Okay, so multiply each thing in the first bracket by the entire second bracket, and then collect any like terms that come up as a result of that. I'm going to give you a minute now that you've seen me do one. Give that a try. So you're going to take here I'm going to show you the next slide. You're going to take this red C and multiply it by the entire second bracket, and the blue -3D and multiply it by the entire second bracket, and then look for like terms. Okay, so we see a bracket with 2 terms and a bracket with 2 terms, so we need to take everything in one of the brackets and multiply it by the entire other bracket. So the red C times the entire second bracket, and then the blue -3D times the entire second bracket. C times C is C squared, and I'm throwing the positive in there just in case. C times 8D, well, that's just 3 things all multiplied together. C times 8 times D. We like to write it like that. We like to put the number first and then the different letters. And we tend to list all the letters in alphabetical order because that helps us spot like terms. So positive 8CD. Now let's take this -3D times C. Again, that's just those 3 things multiplied. So let's put them in the order we like. The -3 first, then the C, then the D. And then the last term, -3D times positive 8D. -3 times positive 8 is -24, and D times D is D squared. So -24 D squared. There's our expansion. So it's really just, you already know how to do this, right? You're just taking this thing and multiplying it through the second bracket, and this thing and multiplying it through the second bracket. Things you already know how to do, you're just doing it twice. And now let's look for like terms. C squared isn't like to anything. D squared isn't like to anything. But in the middle here, we have a CD and a CD. Those are like terms. So positive 8 and -3 adds together to positive 5. So positive 5 CD in the middle. And there is our final answer. Okay, so expanding brackets. Do what you already know how to do twice. What if the second bracket has 3 terms? No big deal. It's just the exact same thing. We're not going to do this whole question. We're just going to set it up. We're going to take that H and that +1. And remember, it's a positive H and a positive 1. And we're going to take each of them separately and multiply it through the entire second bracket, like that. So H times the entire second bracket, +1 times the entire second bracket. And then after you do those multiplications, you would look for any like terms and collect them. I think, yeah, there. So if you want to give that one a try later on your own, there is the answer that you will get if you want to take a screenshot, or you can wait for the video as well, which will get out hopefully tomorrow for you. Okay, so if we had like 5 things in the first bracket and 7 things in the second bracket, oh, well, that would be ugly. But if you did, you would take every single one of the 5 things in the first bracket and multiply it into the second bracket, and then collect all the like terms when you got to the end of that. So these can get bigger and bigger and bigger, but it's just the same process. Take everything in one bracket and multiply it into the second bracket. Okay, final little idea we're going to talk about here today, because this is great to just connect right in. This is section 6.3, but this actually is just more practice expanding brackets, which is great because that's what section 6.2 and 6.1 are all about. So these are called special products because they turn out to have nice little patterns that saves us a lot of time when we're expanding, and more importantly, helps us later on when we try to reverse expanding brackets. It helps us to do that. So you'll see the pattern right away here. So both the brackets are identical, except one has a plus and one has a minus. Y plus 5 and y minus 5. U minus 4 and u plus 4. 3m minus n and 3m plus n. Well, let's expand these and see what happens. And this is great practice for you, so we're going to take a little pause. And what I want you to do is practice your expanding, multiply everything in the first into the second, and then collect like terms, and see if you can spot what pattern emerges from this special type of expansion. Okay, so we have just learned that when we have two brackets that both have two terms, we need to take each of the things in the first bracket and multiply it into the second bracket. By the way, I mentioned this earlier, but I'll just say it again because I know the text does this sometimes. You can also take everything in the second bracket and multiply it into the first bracket and collect like terms. You will get the same answer either way, actually. So we're going to take the y and multiply it into the second bracket, and the plus 5 and multiply it into the second bracket. Y times y is y squared, and y times negative 5 is negative 5y. You can see I'm starting to get lazy not putting the plus there because I've discovered it really doesn't matter, but this one is critical. Once again, don't just go 5y minus 25 and ignore the plus sign. That plus sign has to be there. Plus 5 times y is plus 5y. Plus 5 times negative 5 is negative 25. Oh, look at what happens there. Our like terms, minus 5y plus 5y, actually just cancel out with each other. What a fluke that is. I'm sure that won't happen on both of the other examples. Let's take a look at the second one. That was sarcasm, if anyone missed it. Multiply the u and the negative 4 separately into the second bracket, like so. U times u is u squared plus 4u. Negative 4 times u is negative 4u minus 4 times 4 is 16. And once again, look at that. The middle terms cancel out completely, just leaving u squared minus 16. And the last one, we're hopefully starting to see what's going on here. Some of you could maybe even guess what this expansion is without doing it, which is what our ultimate goal is here. We're going to take the 3m and multiply it into the second bracket, and the negative n in blue and multiply it into the second bracket. 3m times 3m is 9m squared. 3m times n is 3mn plus 3mn. Negative n times 3m is negative 3mn. And again, I follow our convention of writing the number first and then all of the variables in alphabetical order. And negative n times positive n is negative n squared. Once again, the like terms in the middle cancel out. Okay, so we definitely got a pattern going on here. When you see that the two brackets are just the same thing, but one is added and one is subtracted, you can actually skip all this stuff in the middle. I think I wipe it out there. No, I don't. You can skip all this stuff in the middle and just go, you can really just go straight to here. It's going to be y squared minus 25 because the middle term is always going to cancel out. In general, if you see a minus b times a plus b, the result is always a squared minus b squared. The middle like terms cancel. So using that pattern, we can quickly expand things. So look at this, y minus 10 times y plus 10. Oh, you say this is the special pattern. it's exactly the same, but one is subtracted and one's added. So it's just going to be y squared minus 10 squared, 100, like so. This one's a little more involved, but we see it is still the same pattern. One is subtracted, one's added, otherwise they're identical. So this is going to be the first piece squared, 6x cubed y. How do we square that? Oh, I jumped right to the answer. 6 squared is 36. X cubed squared is x to the 6th. X cubed times x cubed is x to the 3 plus 3, x to the 6th. And y squared, well, that's just y squared. So there's that first whole term times itself, squared. And 1 times 1, of course, is just 1, like so. So a quick way to expand. Now, you don't have to use the quick way. You can go the slow way. And that's fine if you don't quite like using this special product to do a quick expansion. But when it comes time to reverse expanding brackets, the second half of chapter 6, we will need to use this special pattern. So there's our first special pattern. A minus b times a plus b is just the first thing squared minus the second thing squared without going through all the steps. Let's try this. We're going to see another special pattern, and you'll notice that now what we have is the exact same thing multiplied by itself. T plus 5 times t plus 5, m minus 3 times m minus 3. Don't be tempted to just go t squared plus 25, because you have to take the t and multiply it into the second bracket, and then the plus 5 and multiply it into the second bracket and collect terms. I'll give you a minute to try those too. Okay, I've shown all the work there without walking through step by step, because we've done a bunch of these now. You take the red t and multiply it into the second bracket, and the blue plus 5 and multiply it into the second bracket. This gives you t squared plus 5t. This gives you positive 5 times t is positive 5t plus 25, 5 times 5. And look at, whereas last time the middle term canceled, this time, with this type of question, the middle term doubles. 5t plus 5t is 10t. Over here, same thing. Take the m, the red m, and multiply it through the second bracket. That blue, that should not be a blue -3 there. It's this -3 over here that should have been blue. Sorry about that on my colors. And we end up with, again, you see the minus 3m. Minus 3m, that becomes -6. So instead of canceling, it doubles. So let's look at this, analyze this pattern. When we have t plus 5 times t plus 5, t plus 5 times itself, the first term ends up being t squared. The last term ends up being positive 5 squared. And the middle term ends up being double 5 times t, 2 times positive 5 times t, 10t. Look, same thing over here. M minus 3 times m minus 3. The first term ends up being m squared. The last term is -3 squared. Remember, a negative times a negative is positive. And the middle term is double 2 times -3 times m, the two things multiplied together. This is called a perfect trinomial square. So and again, if you want, it gives you a quick way to expand. I don't like using this one as much when I'm expanding, but again, it will become important when we are going backwards from expanding. So let's just look at this. You say, oh, look at that. It's a plus 7 times itself. So the first term is going to be a squared. The last term is going to be 7 squared. And the middle is going to be double 7 times a. 2 times 7 times a, plus 14a. Over here, oh, look, it's t minus 6 times itself. The first term is going to be, oh, you try this one. I'll give you 30 seconds to try that. Okay, so something multiplied by itself. The first term will be the t squared. The last term will always be positive, because in this case, it's going to be -6 times -6, which is positive 36. And the middle term is going to be 2 times t times -6, which is -12t, like so. Okay. So like I said, it's not critical because you can always do the full expansion the way we already were, but it's just a little pattern that sometimes helps you do these ones a little bit faster and will become important when we're doing factoring later on. The first one, these have names. The first one is called a difference of squares because look, when you expand it, it ends up being something squared minus something else squared, a squared minus b squared, a difference subtraction of squares. So that's what that's called. And when you either have a plus b times a plus b or a minus b times a minus b, those two are called perfect trinomial squares. And there's the pattern on those. A squared at the front, b squared at the end, double the two of them multiplied together in the middle, either positive or negative. Difference of squares, perfect trinomial squares, special products.